Okay, we're back to maximizing profit. We're going to look at a new approach to that, but first we want to revisit the old way so we can make better sense of our new way of looking at it. So we say that want to find the quantity Q that maximizes profit. So we've seen this in several or a couple other examples. So what I'm going to do is let you try this on your own. So you're trying to find Q that maximizes profit, which means you need a profit function in terms of Q. If you want to find maximum, then you need the derivative and the critical point, and then you need to verify that it produces a global maximum on this interval. So go ahead and stop the video and give it a try. Okay, let's see how you did. So you're going to create the profit function, revenue minus cost, distribute and simplify, so we have our profit function. And then we're trying to find the maximum value, so we need the critical point, which means we need the derivative. Set the derivative equal to 0, and we come up with our critical point is Q is 245. Okay, we need to see if our production quantity is 245, if we will get a maximum profit. So because we are looking at finding maximum profit on a closed interval, here's our interval here, we have to test the endpoints, 0 and 500. When I plug those into the profit, I end up with negative profit for both of those. When I put the critical point, 245, into the profit function, I end up with the largest number. So that's telling me that the maximum profit is when production is at 245 items, and our maximum profit would be $59,875. Okay, so that's old. Now let's look at this in a different light, and let's talk about marginal revenue and marginal cost. Okay, so marginal revenue, remember marginal means the derivative, so it's the rate at which the revenue is changing per item, so to speak, or what is the revenue that we would see by producing and selling an additional item. So our revenue function is 500 minus 2Q. That would calculate the marginal revenue. Or we can use MR, MR of Q, same thing. And we could also write it by switching the order there. All right, so the cost function, if I want the marginal cost, that would be the derivative. So what is the rate of change of cost per item, or to produce, what's the cost to produce one additional item at a given quantity of production? So the derivative is 10, which is a constant. So my marginal cost per item is always, $10. Okay, now, if you recall, we talked about back in chapter 2 where marginal revenue and marginal cost are equal. Okay, so what happens if I set these two equal to each other and solve? I have negative 2Q plus 500 is equal to 10. So that gives me negative 2Q is negative 490. So Q ends up being 245. Where have we seen that before? All right, so what have we found? Our critical point from our profit function is the same as the value that makes marginal revenue equal to marginal cost. If you recall back in chapter 2, we talked about this place where the largest gap between revenue and cost was, because that would give us our maximum profit. And then we talked about that in terms of marginal revenue and marginal cost. Remember, those are the slopes of the tangent line at that point. So where this largest gap is where marginal revenue is equal to marginal cost, because you can see that the slopes of the tangent lines are the same, they're parallel. And then we know then that that's where we have our maximum profit. Is where marginal revenue is equal to marginal cost. Okay, so let's talk about the relationship between the critical point and the value that makes marginal revenue and marginal cost equal. Well, think about it. Maximum profit occurs at the critical point of the profit function. And then we talked about maximum profit in terms of marginal revenue and marginal cost. So we can come up with maximum profit by finding the place where marginal revenue is equal to marginal cost. So it's another way of finding maximum profit. Okay, so let's estimate production level that maximizes profit in terms of marginal revenue, marginal cost. We know that maximum profit occurs when marginal revenue is equal to marginal cost. So here, if I have certain quantities from 5,000 to 10,000, I know the marginal revenue and cost at each of those production levels. Okay, so I can see that if at a quantity of 8,000 items, marginal revenue is equal to marginal cost. So that's where we would see our maximum profit. Anything less than 8,000, the marginal revenue is greater than marginal cost, so you would still be making a profit. Anything greater than 8,000, marginal revenue is less than marginal cost, so you would be losing money. So 8,000 items is basically the critical point of the profit function. And if it's the critical point, we can say that that critical point is a maximum. So profit is a maximum of 8,000. So 8,000 is our best production level if we want to maximize profit.